So here in this problem, it's provided that the mth term of a harmonic progression is n, and the nth term is m. So using these two facts, we need to determine the rth term. Let us begin. So first what we'll do, we'll consider an arithmetic progression. That will make things easier. We will consider the first term to be a and the common difference to be d for a arithmetic progression. So we can find out the mth term of the AP. So the mth term of the arithmetic progression, that will be given by a plus m minus 1 times the common difference d. So this is the value of the mth term of the arithmetic progression, a plus m minus 1 times the common difference d. We're going to label this as number 1. Then the nth term, because that is also provided to us, but we're going to consider the nth term of the arithmetic progression, not the harmonic progression. So nth term of the arithmetic progression will be a plus n minus 1 times the common difference d, or simply an equals to a plus n minus 1 times the common difference d. Let this be 2. However, in the problem it is given here that the mth term of the harmonic progression is n and the nth term of the harmonic progression is m. Now, how do we define the mth term of the harmonic progression? And what we can do, we can take the reciprocal of the mth term of the arithmetic progression. That's the definition of a harmonic progression. So 1 over am, that's going to be the mth term of the harmonic progression, and it's given here that this value is equals to n. And the nth term, which is simply 1 over an, so that's equals to m. So what we'll do, we'll take the reciprocal on both sides. So we get am, this value comes out to be 1 over n. And the nth term, an, comes out to be 1 over m. Now from 1 and 2, we have already defined the mth term as well as the nth term. All we have to do is replace the value of am with a plus m minus 1 times the common difference d. This will be equals to 1 over n. So let's label this as number 3. And the nth term, so we can use equation number 2 to replace it with a plus n minus 1 times the common difference d. So this will be equals to 1 over m. So let this be number 4. Now what we'll do, we'll try to use equation 3 and equation 4 to find out the value of the first term a and the common difference d. So let's do 3 minus 4. So if we subtract 4 from 3, we'll be left with m minus n times d on the left hand side, and on the right hand side we have m minus n divided by m times n. So this gives us the value of d. So the common difference d comes out to be 1 over m times n. Now that we have the value of the common difference d, we can use either equation 3 or equation 4 to obtain the value of our first term. So equation number 3, so that gives us a, so that's the first term, a, added to m minus 1 times the common difference d. So that's 1 over mn. So this will be equals to 1 over n. So we have a plus m over m times n minus 1 over m over n equals to 1 over n. So we can factor out 1m from the numerator and 1 from the denominator. So that leaves us with a equals to 1 over mn, because clearly 1 over n and 1 over n from the left hand side and the right hand side will get cancelled out. So we have obtained the value of d when we have obtained the value of the first term a. So what we have to do here in the problem is to find out the rth term of the harmonic progression. But what we'll do, we'll try to find out the rth term of the arithmetic progression. And once we have that value, what we'll do, we'll simply take the reciprocal. So let's find out. So the rth term of the arithmetic progression. So this will be given by a plus r minus 1 times the common difference d. So what's a? That's simply 1 over m times n plus r. So r minus 1, let's keep it as it is, r minus 1 times the common difference. So that's 1 over m times n. Okay, so this will be equals to, so we have 1 over mn plus r over m times n minus 1 over m times n. So the first and the third term cancels out, and finally that leaves us with r over mn. So here this is the rth term of the arithmetic progression, but in our problem we are asked to find out the rth term of the harmonic progression. So therefore the rth term of the harmonic progression, so that will be given by the reciprocal of the rth term of the arithmetic progression. So that's simply given by m times n. divided by r. So this is going to be the final value.